process accelerates dramatically, potentially leading to the complete disintegration of the nucleus. Such comets are often referred to as sun-grazers. These are comets with orbits that take them perilously close to the sun. While some survive these fiery encounters, others do not. For instance, Comet Ison, which was hailed as a potential comet of the century in 2013, disintegrated when it passed just 1.2 million kilometers from the sun's surface. Interestingly, not all comets face destruction this way. Factors such as the size of the nucleus and its composition determine whether a comet can endure the sun's intense heat and gravity. Larger, denser comets with more solid cores are better equipped to survive, while smaller or loosely packed comets tend to break apart. These dramatic endings remind us of the delicate balance in the cosmos. While comets have survived billions of years in the depths of space, their ultimate fates are often sealed by the very star that gives them their brilliant glow. Observing such events allows scientists to understand the structural integrity and composition of these ancient objects. Comet impacts have shaped Earth's history. Comets may be beautiful to behold, but their encounters with Earth have been far from peaceful. Throughout history, comets have collided with our planet, leaving behind evidence of their devastating power. These impacts are thought to have played significant roles in shaping Earth's surface and even influencing the course of life. One of the most famous examples is the Chicxulub impact, which is widely believed to have caused the mass extinction event that wiped out the dinosaurs 66 million years ago. While this event is often attributed to an asteroid, some scientists propose that a comet might have been the culprit. The immense energy released during such an impact can cause catastrophic climate changes, including global fires and long-lasting darkness from dust clouds. On a more positive note, comet impacts may have also delivered essential ingredients for life, such as water and organic molecules, during Earth's early history. These collisions could have jump-started the chemical processes that eventually led to the emergence of life. Today, astronomers actively monitor near-Earth objects to assess the potential threat of future impacts. Comets with highly eccentric orbits can be unpredictable, making them more challenging to track. Despite the risks, these ancient collisions are a reminder of the dynamic and interconnected nature of our solar system. Comets have inspired myths and superstitions. Long before modern science unraveled the mysteries of comets, these celestial objects were shrouded in myth and superstition. Their sudden appearances in the night sky, often accompanied by brilliant tales, sparked awe, fear, and speculation among ancient civilizations. Comets were frequently seen as omens, their presence interpreted as harbingers of significant events. In ancient China, comets were referred to as stars with long hair, and were often viewed as warnings of political upheaval or natural disasters. Similarly, in medieval Europe, comets were associated with doom and misfortune. Halley's Comet, for instance, was blamed for events like the Black Death and the Norman conquest of England in 1066. Not all interpretations were negative, though. In some cultures, comets were seen as divine messengers or symbols of change and renewal. For example, the Aztecs associated comets with the arrival of gods. These cultural interpretations reveal how comets have captivated human imagination across time and geography. Even today, comets inspire wonder and creativity. Their appearances have been immortalized in art, literature, and music, reflecting humanity's enduring fascination with the cosmos. By studying their science, we bridge the gap between myth and reality, understanding these cosmic wanderers as both agents of mystery and messengers of the stars. Comets may hold clues to the origins of life. One of the most exciting aspects of comet research is its potential to unlock the secrets of life's origins. Comets are rich in organic molecules, including amino acids, which are the building blocks of proteins. These discoveries suggest that comets could have delivered the raw materials necessary for life to emerge on Earth. The Rosetta mission's analysis of Comet 67P/Churyumov-Gerasimenko revealed the presence of glycine, a simple amino acid, as well as phosphorus, a key element in DNA and cell membranes. These findings strengthen the hypothesis that comet impacts played a role in seeding Earth with prebiotic chemistry billions of years ago. Furthermore, comets might not be unique in this role. The panspermia theory posits that life, or the precursors of life, could be distributed throughout the universe via comets and asteroids. If this is true, then studying comets could provide insights into the potential for life elsewhere in the cosmos. By examining the molecular composition of comets, scientists aim to answer fundamental questions about how life begins and evolves. These icy bodies are more than just remnants of the solar system's formation. They are key players in the grand narrative of life itself. Some comets visit only once, while some comets, like Halley's Comet, return to the inner solar system on predictable schedules. Others are one-time visitors. These non-periodic comets originate in the Oort cloud and have hyperbolic orbits, meaning they are on a one-way trip through the solar system, never to return. Comet C2012 S1, ISON, was a notable example of a non-periodic comet. Discovered in 2012, it was initially expected to become incredibly bright during its close approach to the Sun. Unfortunately, it disintegrated during this journey, but its fleeting presence captivated astronomers and the public alike. What makes these comets so fascinating is their pristine condition. Because they spend most of their existence in the distant Oort cloud far from the Sun's influence, they retain their original composition. When they enter the inner solar system for the first time, they offer a unique opportunity to study unaltered materials from the solar system's formation. These rare visitors remind us of the vastness and complexity of the solar system. Each non-periodic comet brings with it a unique story, offering a brief but illuminating glimpse into the outer reaches of our cosmic neighborhood. Comets are a source of meteor showers. Meteor showers, those dazzling displays of shooting stars, are often the result of comets. As a comet travels through space, it sheds debris along its orbital path. When Earth crosses this debris trail, tiny particles enter our atmosphere and burn up, creating streaks of light. One of the most famous meteor showers, the Perseids, occurs every August and is associated with Comet Swift-Tuttle. Similarly, the Leonids, known for their spectacular meteor storms, are linked to Comet Tempel-Tuttle. These events are predictable and eagerly anticipated by stargazers around the world. The size and speed of the debris determine the brightness and frequency of the meteors. Larger particles create brighter meteors, sometimes called fireballs, while smaller ones produce faint streaks. Despite their fiery appearance, these meteors are typically no larger than a grain of sand. Meteor showers connect us to the journey of comets, highlighting their influence on Earth even from millions of kilometers away. Watching a meteor shower is a reminder of our planet's place in the solar system and the intricate interplay between celestial bodies. Thank you for joining us on this fascinating journey through the world of comets. From their icy origins to their role in shaping life on Earth, comets continue to inspire awe and curiosity. If you enjoyed this deep dive, don't forget to like, share, and subscribe to InnoVision Tech. Hit the bell icon to stay updated on all our cosmic explorations. Until next time, keep reaching for the stars with us. Have you ever wondered how vast and interconnected the universe truly is? Galaxy clusters and superclusters are among the largest structures in existence, holding secrets that redefine our understanding of space. Did you know some of these clusters are bound by mysterious forces like dark matter, or that their sheer size stretches the limits of imagination? Join us as we explore 7 surprising facts about galaxy clusters and superclusters, unraveling the cosmic threads that weave our universe together. The immense size of galaxy clusters. Imagine a structure so vast, it stretches across millions of light-years, and holds thousands of galaxies within it. That's the mind-blowing reality of galaxy clusters. These colossal gatherings of stars, planets, and cosmic dust are like bustling cities in the universe, each teeming with activity on a scale that's hard to wrap your head around. At the center of many clusters, you'll often find a massive elliptical galaxy that acts like a gravitational anchor, pulling in smaller galaxies and holding everything together. These central giants are surrounded by spirals, lenticulars, and irregular galaxies, each moving in a gravitational dance that's been going on for billions of years. But here's the wild part, it's not just the galaxies themselves. Between them lies a superheated plasma called the intracluster medium, glowing in X-rays and holding clues about the cluster's history and formation. What's even more incredible is that these clusters don't just sit in isolation. They're part of an even grander structure called the cosmic web, connected by filaments of dark matter and gas that stretch across the observable universe. Galaxy clusters form the nodes in this vast network, showing us how matter is distributed on the largest scales. And remember, we're not just talking about a few stars or galaxies here, we're talking trillions of stars, planets, black holes, and other celestial wonders, all crammed into these epic clusters. Studying galaxy clusters doesn't just give us a snapshot of the universe's grandeur, it reveals its secrets. From the mysterious role of dark matter to the processes that shape galaxies themselves, these clusters are like a treasure chest for astronomers. They're a reminder of just how vast, interconnected, and awe-inspiring the cosmos truly is. Dark matter holds them together. Think about this. Without an invisible, mysterious force, galaxy clusters would completely fall apart. That force? Dark matter. It's the glue of the universe, holding these gigantic clusters together even when they should be flying apart. But here's the kicker, no one's ever seen it directly. Scientists figured out dark matter was there because the math just didn't add up. When they measured the visible mass of galaxies, stars, planets, gas clouds, it wasn't nearly enough to account for the gravitational pull holding clusters together. The galaxies within these clusters are moving at such insane speeds that, without something extra adding mass, they'd be flung into space like confetti at a party. That's where dark matter steps in, making up about 85% of the total mass in a cluster. What exactly is it? That's still a cosmic mystery. It doesn't emit light, absorb it, or interact with regular matter in any way we can see, touch, or measure, at least not yet. We know it's there because of its gravitational effects. It bends light from distant objects in a phenomenon called gravitational lensing, acting like a cosmic magnifying glass. Without dark matter, we wouldn't see those telltale light distortions around clusters, which have become key evidence of its existence. Dark matter isn't just a supporting actor in the galaxy cluster drama, it's the star of the show. Without it, the universe as we know it wouldn't exist. Galaxies wouldn't have formed, clusters wouldn't hold together, and we wouldn't be here to marvel at the cosmos. It's the invisible scaffolding of the universe, reminding us that some of the most important pieces of reality are the ones we can't see. How's that for a cosmic plot twist? Superclusters are cosmic giants. If you think galaxy clusters are impressive, wait until you hear about superclusters. These are the true titans of the cosmos, sprawling structures made up of multiple galaxy clusters bound together by gravity. Superclusters are so vast that they stretch across hundreds of millions of light-years, forming intricate webs that shape the very structure of the universe. Picture a network of filaments and nodes connecting glowing clusters of galaxies, like a cosmic spiderweb on an unimaginable scale. The size of superclusters is so enormous that it's difficult to wrap your head around it. Take the Laniakea supercluster, for example. This is the colossal cosmic neighborhood that our Milky Way calls home. It spans over 500 million light-years and contains around 100,000 galaxies, each one packed with billions of stars. To travel across Laniakea at the speed of light, it would take you 5 million centuries. Yes, centuries. And that's just one supercluster in a universe teeming with them. What makes superclusters even more fascinating is how they're arranged in the cosmic web. Instead of being randomly scattered, they form the universe's large-scale structure. Superclusters are connected by filaments of dark matter, with vast voids of empty space in between. Imagine looking at a three-dimensional map of the cosmos, where the bright points represent galaxies and clusters, and the threads connecting them reveal the invisible scaffolding of dark matter. This structure tells the story of how the universe evolved, from a hot, dense state to the sprawling expanse we see today. Despite their immense size and influence, superclusters aren't permanent. Over billions of years, their gravitational pull will eventually overcome their cosmic bonds, and the galaxies within them will drift apart as the universe continues to expand. It's a humbling reminder of how even the mightiest structures in the cosmos are subject to the relentless forces of time and space. Superclusters are a testament to the universe's complexity, showing us how small we really are while inspiring awe for the grandeur of the cosmos. The role of gravitational lensing. Gravity doesn't just hold galaxies and stars in place, it bends light itself, creating one of the most fascinating phenomena in the cosmos: gravitational lensing. This happens when the immense gravitational pull of a massive object like a galaxy cluster warps the space around it, bending light from more distant objects. Imagine looking through a cosmic magnifying glass that stretches and distorts the view of what lies behind it. It's both a scientific marvel and a natural work of art. Gravitational lensing isn't just a curiosity, it's an invaluable tool for astronomers. By analyzing these cosmic distortions, scientists can uncover details about the universe that would otherwise remain hidden. For example, when light from a distant galaxy passes through a galaxy cluster acting as a lens, it gets magnified, allowing astronomers to observe faint galaxies billions of light-years away. These magnifications have given us glimpses of the early universe, helping us study how galaxies formed and evolved. But that's not all. Gravitational lensing also provides a window into the mysterious world of dark matter. Since dark matter doesn't emit, absorb, or reflect light, it's invisible to our telescopes. However, its immense gravitational influence affects how light bends around galaxy clusters. By studying these lensing effects, scientists can map the distribution of dark matter, uncovering its presence and understanding how it contributes to the structure of the universe. Without gravitational lensing, our knowledge of dark matter would be far more limited. Perhaps the most stunning examples of gravitational lensing are the visual phenomena it creates. Einstein rings, arcs, and multiple images of the same distant object are all results of light taking different paths around a massive lensing object. These cosmic spectacles are a testament to the power of gravity and the vastness of the universe. Gravitational lensing turns the sky into a canvas, revealing both the beauty and the secrets of the cosmos in ways we are only beginning to comprehend. The extreme temperatures of the intracluster medium. The space between galaxies in a cluster isn't empty, it's filled with a searing hot plasma called the intracluster medium, or ICM. This vast expanse of gas reaches mind-boggling temperatures of tens of millions of degrees. Imagine an environment so extreme that atoms are stripped of their electrons, leaving behind a sea of charged particles. The intracluster medium is not just a space filler, it's a key component of galaxy clusters, accounting for more mass than the galaxies themselves. This scorching plasma emits intense X-rays, making galaxy clusters some of the brightest X-ray sources in the universe. By observing these X-rays, astronomers can study the composition, temperature, and density of the ICM, revealing the intricate details of how galaxy clusters form and evolve. The X-ray emissions also allow us to measure the mass of the clusters, providing crucial insights into the influence of dark matter and the role it plays in binding these cosmic giants together. The extreme temperatures of the intracluster medium are powered by the gravitational energy of the cluster itself. When smaller clusters or galaxies collide and merge into a larger cluster, the resulting shockwaves heat the ICM to these incredible temperatures. These cosmic collisions are on a scale that's hard to fathom, but they're essential for shaping the structure of the universe as we see it today. The heated plasma also carries a wealth of information about the violent history of galaxy clusters and their ongoing interactions. What's truly fascinating is how the ICM interacts with the galaxies it surrounds. The hot plasma exerts pressure on the galaxies, stripping away their gas and stalling star formation in a process known as ram pressure stripping. This dynamic interplay between galaxies and the intracluster medium shows how interconnected the universe is. The ICM isn't just a byproduct of galaxy clusters, it's a vital player in the cosmic ecosystem, influencing everything from star formation to the growth of the largest structures in the universe. The Great Attractor, a cosmic mystery. Deep within the vast cosmic web, an invisible force draws galaxies toward a single point in space, a phenomenon scientists call the Great Attractor. This mysterious region, located about 150 to 250 million light-years away from us in the direction of the constellation Centaurus, exerts a gravitational pull so massive that it's reshaping the movement of entire galaxy clusters. It's not just a small anomaly, this enigmatic force impacts the trajectory of our own Milky Way and countless neighboring galaxies within the Laniakea supercluster. The Great Attractor isn't fully visible to us because it lies in what astronomers call the zone of avoidance, a region of the sky obscured by the dense plane of our galaxy, filled with stars, gas, and dust. Even so, researchers have used radio waves and X-rays which can penetrate the Milky Way's dense shroud, to begin piecing together the secrets of this gravitational behemoth. What they've found so far is awe-inspiring. The Great Attractor appears to be a region of immense mass, likely populated by enormous galaxy clusters and a significant amount of dark matter. What makes this force even more intriguing is its potential role in the larger cosmic structure. Some scientists theorize that the Great Attractor might be part of an even larger feature called the Shapley supercluster, the most massive concentration of galaxies in our observable universe. If this theory holds true, the Great Attractor isn't just a local cosmic influence but a pivotal piece in the grand design of the universe. Observing the flow of galaxies around this region reveals the gravitational dominance it commands, stretching its influence far beyond what we might initially imagine. Despite decades of study, the true nature of the Great Attractor remains one of the universe's most tantalizing mysteries. Is it a massive cluster of galaxies, a dense web of dark matter, or perhaps something entirely unforeseen? As technology advances, astronomers continue to peel back the layers of this cosmic enigma, promising us a deeper understanding of the forces that shape the very fabric of our universe. Until then, the Great Attractor remains a captivating reminder of how much we have yet to uncover about the vast interconnected cosmos. Superclusters are still expanding. Superclusters, the colossal arrangements of galaxy clusters stretching across hundreds of millions of light-years, are far from static. These cosmic giants are still expanding, driven by the relentless force of the universe's expansion itself. This vast movement originates from the aftermath of the Big Bang, and is powered by an elusive and mysterious entity known as dark energy. Superclusters might seem like immovable structures, but in reality, they are dynamic participants in the ever-evolving story of the cosmos. One of the most fascinating aspects of their expansion is how it alters the relationship between galaxies and clusters within them. Gravity works to hold galaxies together within their clusters, forming dense, interlinked webs, while dark energy exerts an opposing force, pulling these clusters farther apart on a grander scale. This tug-of-war creates a stunning visual when mapped out, intricate, thread-like filaments of galaxies stretching across an otherwise empty void. These structures aren't just expanding, they're evolving, with gravity slowly tightening the bonds within clusters while the overall web continues to stretch outward. The expansion of superclusters also shapes the way galaxies move and interact with each other. While some galaxies might collide and merge due to local gravitational pulls, others are being swept apart by dark energy's influence. For example, even as the Milky Way and Andromeda galaxies are on a collision course, they are being carried along with the local group toward larger structures like the Virgo supercluster, and beyond that, the Laniakea supercluster. However, as time goes on, galaxies outside of our local gravitational influences will recede farther and farther into the vastness of space, eventually disappearing from view. This ongoing expansion presents a paradoxical beauty. The universe is simultaneously pulling galaxies together in some regions while pushing everything apart on a larger scale. It's a stark reminder of the duality at play in the cosmos, a world of unity and separation, gravity and dark energy, clustering and expansion. These massive superclusters serve as both the architects of cosmic structures and symbols of the universe's ceaseless transformation. By observing this endless expansion, scientists gain deeper insights into the fundamental forces shaping the universe and glimpse its ultimate fate. Galaxy clusters and superclusters are incredible cosmic phenomena that continue to captivate and challenge our understanding of the universe. From the fiery temperatures of the intra-cluster medium to the enigmatic pull of the Great Attractor, each discovery reveals more about the forces shaping our cosmos. If you found this exploration as thrilling as we did, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep exploring the wonders of the universe with us.
Have you ever wondered about the astonishing secrets the universe holds? Are you curious about the incredible discoveries that have changed our understanding of space? From black holes to distant exoplanets, the cosmos is full of awe-inspiring phenomena waiting to be explored. Join us as we uncover 15 mind-blowing space discoveries you need to know. Join us as we delve into these amazing findings and see how they expand our knowledge of the universe. The first image of a black hole. In April 2019, the Event Horizon Telescope collaboration achieved a monumental milestone by capturing the first ever image of a black hole. This groundbreaking image revealed the supermassive black hole at the center of the galaxy M87, located about 55 million light-years from Earth. The image showcased a bright ring of light encircling a dark shadow, the event horizon, beyond which no light or matter can escape. This achievement was made possible by synchronizing 8 radio telescopes worldwide, creating an Earth-sized virtual telescope. This observation not only confirmed the existence of black holes, but also provided critical support for Einstein's theory of general relativity. The EHT's success marks the beginning of a new era in studying black holes, promising to reveal more about these mysterious cosmic giants. The discovery of gravitational waves. In 2015, the Laser Interferometer Gravitational Wave Observatory, or LIGO, made history by detecting gravitational waves for the first time. These ripples in space-time, predicted by Einstein's general theory of relativity, were caused by the collision of 2 black holes over 1 billion light-years away. This discovery opened a new window for observing the universe, allowing scientists to study cosmic events that were previously invisible. Gravitational waves have since been detected from multiple sources, including merging neutron stars. These observations have provided invaluable insights into the behavior of matter under extreme conditions and have confirmed the existence of binary black hole systems. The study of gravitational waves continues to revolutionize our understanding of the universe and its most violent events. The discovery of thousands of exoplanets. The search for exoplanets, planets outside our solar system, has been one of the most exciting areas of astronomy. The Kepler Space Telescope, launched in 2009, revolutionized this field by discovering thousands of exoplanet candidates. Among these, many are Earth-sized and reside in their star's habitable zone, where conditions might be right for liquid water to exist. Notable discoveries include Kepler 186f, an Earth-sized planet in the habitable zone of its star, and the TRAPPIST-1 system, which has 7 Earth-sized planets, 3 of which are in the habitable zone. These discoveries have profound implications for the search for extraterrestrial life and have expanded our understanding of the diversity of planetary systems in the galaxy. Hubble's Deep Field Images. The Hubble Space Telescope has captured some of the most iconic images of the universe, including the Hubble Deep Field and Hubble Ultra Deep Field. By focusing on a tiny, seemingly empty patch of sky for extended periods, Hubble revealed thousands of distant galaxies, some of which are among the oldest and most distant objects ever observed. These deep field images provide a glimpse into the universe's past, showing galaxies as they were billions of years ago. They have significantly advanced our understanding of galaxy formation and evolution, and have demonstrated the vastness and richness of the cosmos. The Hubble Deep Field images remain a testament to the power of space telescopes to explore the farthest reaches of the universe.
The Cassini-Huygens mission to Saturn.
The Cassini-Huygens mission, a collaboration between NASA, ESA, and ASI, provided an unprecedented view of Saturn and its moons. Launched in 1997, the Cassini spacecraft spent 13 years orbiting Saturn, sending back stunning images and valuable data. Among its most significant discoveries was the detection of active geysers on Enceladus, indicating a subsurface ocean that could potentially harbor life. The mission also revealed the complexity of Titan, Saturn's largest moon, with its lakes and rivers of liquid methane. Cassini's observations have transformed our understanding of the Saturnian system and highlighted the potential for life on its moons. The mission's legacy continues to influence planetary science and exploration.
Mars rover's discoveries.
Mars exploration has been significantly advanced by rovers such as Spirit, Opportunity, Curiosity, and Perseverance. These rovers have provided detailed analyses of Martian geology and climate, revealing evidence of ancient water activity and the potential for past life on Mars. Spirit and Opportunity, which landed in 2004, discovered signs of ancient riverbeds and minerals that form in the presence of water. Curiosity, which landed in 2012, found evidence of ancient lakes and organic molecules, suggesting that Mars could have supported microbial life in the past. Perseverance, which landed in 2021, is searching for signs of ancient life and collecting samples for future return to Earth. These rovers have revolutionized our understanding of Mars and paved the way for future human exploration. The discovery of dark energy. In 1998, astronomers made a groundbreaking discovery that the universe's expansion is accelerating, driven by a mysterious force known as dark energy. This discovery was based on observations of distant supernovae, which appeared dimmer than expected, indicating an increasing expansion rate. Dark energy is thought to make up about 68% of the universe's total energy content, yet its nature remains one of the biggest mysteries in cosmology. Understanding dark energy is crucial for determining the universe's fate. If the expansion continues to accelerate, it could lead to scenarios such as the Big Freeze, where galaxies drift apart and stars eventually burn out. The discovery of dark energy has profound implications for our understanding of the cosmos and the fundamental forces that govern its evolution.
The Kepler Space Telescope's exoplanet discoveries.
The Kepler Space Telescope has been instrumental in discovering thousands of exoplanets, greatly expanding our knowledge of planetary systems. By monitoring the brightness of over 150,000 stars, Kepler identified exoplanets through the transit method, detecting the slight dimming of a star as a planet passes in front of it. Among Kepler's most significant discoveries are Earth-sized and potentially habitable exoplanets. Kepler 186f, an Earth-sized planet in the habitable zone of its star, was a milestone in the search for Earth-like planets. Kepler's findings have shown that planets are common in the galaxy, and that many stars host multiple planets, suggesting that the conditions for life might be widespread.
The discovery of water on Mars.
The discovery of water on Mars has been a significant milestone in the exploration of the red planet. Evidence of water in various forms, including ice, vapor, and briny liquid, has been found, suggesting that Mars once had a more hospitable environment. The Mars Reconnaissance Orbiter detected hydrated salts in recurring slope lineae, indicating seasonal flows of briny water. Radar data from the Mars Express spacecraft revealed a subsurface lake beneath the southern polar ice cap. These discoveries have significant implications for the planet's potential to harbor life and for future human exploration. Water is a crucial resource for sustaining life and could be used for drinking, growing food, and producing fuel. Neutron star mergers. The observation of neutron star mergers has provided new insights into some of the most extreme events in astrophysics. In 2017, LIGO and Virgo detected gravitational waves from the merger of two neutron stars, followed by a gamma-ray burst and observations across the electromagnetic spectrum. This event, known as GW170817, marked the first multi-messenger observation, combining gravitational waves and light. The collision of neutron stars produces heavy elements like gold and platinum, helping scientists understand their origins. Observing these mergers has provided valuable information about the speed of gravitational waves, the properties of neutron stars, and the rate of neutron star mergers in the universe. Multi-messenger astronomy has become a powerful tool for studying the cosmos.
Fast radio bursts.
Fast radio bursts, or FRBs, are intense bursts of radio waves lasting only milliseconds but releasing enormous amounts of energy. Discovered in 2007, dozens of FRBs have since been detected, with some traced back to distant galaxies. The origins of FRBs remain largely unknown, but they are thought to originate from powerful astrophysical events. Repeating FRBs, such as FRB 121102, have provided additional clues, allowing astronomers to study these bursts in more detail. FRBs offer a unique opportunity to study the intergalactic medium and the large-scale structure of the universe. As radio waves travel through space, they interact with matter, providing information about the density and composition of the intergalactic medium.
New Horizons exploration of Pluto.
The New Horizons mission, launched by NASA in 2006, provided the first close-up images of Pluto and its moons. In 2015, New Horizons flew by Pluto, capturing detailed images and data that revealed a complex and diverse world. Among the most striking discoveries was the heart-shaped region called Tombao Regio, consisting of a vast, icy plain known as Sputnik Planitia. New Horizons also discovered active geology on Pluto, including nitrogen ice glaciers and towering ice mountains. The mission's findings extended beyond Pluto to its largest moon, Charon, which exhibited a varied landscape with deep canyons and a large equatorial ridge. The data from New Horizons has transformed our understanding of Pluto and the outer solar system. Oumuamua, the first interstellar visitor. In 2017, astronomers detected an unusual object passing through the solar system, later named Oumuamua. This was the first known interstellar object to enter our solar system, traveling on a trajectory that indicated it originated from outside our solar neighborhood. Oumuamua's characteristics were puzzling, including its elongated shape and non-gravitational acceleration. The discovery of Oumuamua provided a rare opportunity to study an object from another star system. Its origins and nature remain subjects of intense debate, with hypotheses ranging from a fragment of a larger body to an interstellar comet. Oumuamua confirmed that objects from other star systems can pass through our solar system, offering potential clues about the formation and evolution of planetary systems. The Cosmic Microwave Background, CMB. The Cosmic Microwave Background, CMB, is the afterglow of the Big Bang, providing a snapshot of the universe when it was just 380,000 years old. Observations of the CMB have been crucial for understanding the early universe, its composition, and its evolution. Missions like COBE, WMAP, and Planck have provided detailed measurements of the CMB, revealing its temperature fluctuations and polarization. These observations have confirmed key aspects of the Big Bang theory and provided precise measurements of the universe's age, composition, and geometry. The study of the CMB continues to be a vital tool for cosmology, helping scientists test theories of the universe's origin, evolution, and fundamental physics. Star formation insights from ALMA. The Atacama Large Millimeter Submillimeter Array, ALMA, in Chile has revolutionized our understanding of star formation and the early stages of planetary systems. By observing the universe in millimeter and submillimeter wavelengths, ALMA can peer through dust clouds that obscure visible light, providing detailed images of star-forming regions and protoplanetary disks. ALMA's observations have revealed intricate structures in protoplanetary disks, such as gaps and rings, indicating the presence of forming planets. It has also detected complex organic molecules in these disks, providing clues about the chemical processes that lead to the formation of life-bearing planets. ALMA's findings are helping to answer fundamental questions about the formation and evolution of planetary systems. These 15 mind-blowing space discoveries have expanded our understanding of the universe and opened up new frontiers in astronomy and astrophysics. From black holes to exoplanets and interstellar visitors, each discovery brings us closer to unraveling the mysteries of the cosmos. If you enjoyed this exploration, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep discovering the world's wonders with us.
Have you ever gazed at a comet streaking across the night sky and wondered what secrets it holds? These icy wanderers are remnants from the birth of our solar system, harboring mysteries about our cosmic origins. Did you know comets can have tails millions of kilometers long, or that they might have seeded life on Earth? Join us as we uncover 10 fascinating facts about comets, diving deep into their captivating science and the tales they tell about our universe. Comets are time capsules of the early solar system. Comets are often referred to as cosmic time capsules. These icy bodies are remnants from the formation of our solar system over 4.6 billion years ago. Made up of dust, rock, and frozen gases, they offer a unique glimpse into the primordial materials that existed during the early stages of planetary formation. Unlike planets or moons, which have undergone significant geological and chemical changes, comets remain largely unchanged, preserving the conditions of the early solar system. The origin of comets lies in two primary regions, the Kuiper Belt, located beyond Neptune, and the Oort cloud, a distant spherical shell surrounding the solar system. These regions are like cosmic vaults, holding countless icy objects. When gravitational forces disturb a comet, it begins its journey toward the sun, revealing its spectacular tail and coma as it heats up. Scientists study comets to understand the building blocks of planets and life itself. Missions like Rosetta and Deep Impact have provided invaluable data by analyzing cometary materials. For example, the discovery of organic molecules on comets suggests they might have played a role in delivering the precursors of life to Earth. Comets remind us of our solar system's infancy, acting as frozen messengers from a time long before life began. By studying these ancient travelers, we piece together the story of our cosmic origins. Comets have two tails, and they're fascinating. When a comet approaches the sun, it undergoes a dramatic transformation. The sun's heat vaporizes the ice, releasing gas and dust that form the coma, the glowing envelope around the nucleus. But the most iconic feature of a comet is its tail, or rather tails. A comet typically has two distinct tails, the ion tail and the dust tail. The ion tail is composed of charged particles that interact with the solar wind, creating a straight, glowing trail that points directly away from the sun. Meanwhile, the dust tail is made up of larger particles which are pushed away by sunlight and follow a more curved path along the comet's orbit. The dual tails can extend millions of kilometers into space, creating a breathtaking celestial phenomenon visible from Earth. What's remarkable is how these tails reveal the composition and activity of the comet. The ion tail glows due to the excitation of gas molecules, while the dust tail reflects sunlight, appearing golden or white. Observing these tails allows scientists to study the materials ejected from the comet's nucleus.